So this question concerns the numbers from 1 to n being written in a circle. You want to write the numbers from 1 to n in a circle obeying three constraints as written in the question. The first two constraints says that as you write the numbers around the circle, two numbers which are next to each other must have opposite parity. That means one of them must be even and the other must be odd. And there's this second condition that adjacent numbers must not be consecutive. So you can't have a 3 next to a 2, for example. We're also given in the question that n is at least 2. Well, n can't be 2 because then 1 would be next to 2, so we can forget about that. That means that one of our numbers is 3. And let's see what the consequences are of that. So, what are the neighbours of 3? Well, they can't be 2 or 4 because those are one different from 3. On the other hand, they must be even. So you need 2 more even numbers. The next 2 even numbers are 6 and 8. So that tells us we're going to need an 8. So we know n is at least 8. Now, in fact, 8 can be achieved. And let's see how to do this, first of all, by bare hands. Well, the neighbours of 3 are going to be 6 and 8, and it doesn't matter which way around you put them. Shall we say 6 goes here and 8 goes here. Now we think about the neighbours of 6. Well, the neighbours of 6 must be odd. Can't be 5 because 6 minus 5 is 1. So the only options are 1 and 7. But 7's not allowed, right, because it's 1 more than 6. So a 1 has to go here. What about on this side? Well, this number's got to be odd because it's next to an even number, but it can't be a 3 or a 1 because we've used those, and it can't be a 7 because that's one different from 8. So it has to be a 5. Now let's look at the neighbours of 1. Well, we know one of them is 6. The other one has to be even as well. It can't be 2 because that differs from 1 by 1. It can't be 6 or 8, so it has to be 4. What about this number here? It must be even because it's a neighbour of 5, and it can't be 4, 6, or 8. So it has to be, the only number left, 2. And now there's only one number remaining, and that's 7. Does it work? If I put it there, are these of opposite parity? Yes. Are these of opposite parity? Yes. And are these numbers here differing by 1? No, they're not. Everything's fine. So we've got an example of an arrangement. And we could get another arrangement by reflecting the thing, exchanging 6 and 8. But otherwise, everything was forced. So if we tried to find a pattern like this that obeyed the original rules for a large value of n, it would be very easy. You could just fill in stuff almost at random, just as long as it obeyed the conditions at the beginning, and with any luck, you're likely to be able to finish. But with 8 being the smallest possible solution, this has imposed a lot of restrictions on how we write down the numbers. And so there's a lot of structure in this pattern. So much structure that you can actually see it in other ways. So think about clock arithmetic. So if you're 3 hours after 11 o'clock, you're 2 o'clock. So working in clock arithmetic, 11 plus 3 is 2. You wrap around. We can play clock arithmetic here, but not with 12 hours in the day, with 8 hours in the day. So look at the pattern. 1, add 5, add 5. You see 6 plus 5 is 11, which is 3, because it's 3 more than 8. Plus 5, plus 5, plus 5, plus 5, plus 5, and so on. Now, it's clear how that works, because if you start off with any number and you add 5, you change its parity, even with the clock business, even with the wrapping around. So adding 5 guarantees that as you go round, the numbers will alternate in parity. Also adding 5 means that you guarantee that consecutive numbers, as you go round, don't differ by 1, because they differ by 5 or 3 if you look at the other way around. So the only miracle there is that if you start with 1, or indeed any number, and you keep adding 5, you're fixing the numbers in such a way as to obey the original conditions. The miracle is that you come back to the beginning. So what happens when n is 10? Well, in that case, you can play this game of adding a fixed quantity on, but you need to use a clock with 10 hours in the day, and the number that you need to add on is, well, if you go around one way, it would be 3. If you went round the other way, it would be 7. If you tried n equals 12, then, well, things get a lot more interesting and messy. I leave it to you to investigate. Why did I look at 8, 10, and 12? Why didn't I look at 9 and 11? Think about that.